so take out your tan. We have 4 sine squared x minus 3 equals 0. Okay, that's really all we can do. No, we still got to solve. But as far as there's no identity here. I could take out a sine squared if I wanted to and replace it, but I would be replacing it with 1 minus cosine squared, so you'd be replacing it with something more complicated. So I don't think that that's a good idea. Let's just tee this up. So on the one hand, tangent of x could equal 0. On the other hand, sine squared of x would equal what? 3/4. Good. This one just needs to be taken a step further because I got to get sine all by itself. But how do you undo a square? Square root. So just be careful on this. When you take the square root of anything on both sides, you have to remember plus or minus. By the way, that immediately tells me that all 4 quadrants are going to get touched here. 2 for the positive and 2 for the negative. And then when you take the square root of a fraction, you do the square root of the numerator, which has to stay root 3, and the square root of the denominator, which is 2. So we have a reference angle for that. What is it? Are we in degrees? Doesn't say. Sure. We're going to keep it degrees. So our reference angle is 60, and because we have plus or minus, we have to hit the 2 positive quadrants for sine and the 2 negative quadrants for sine. So we're going to hit all 4. So in your first quadrant, it'll be 60 degrees as your answer. In your second quadrant, it will be 120. Good. Third quadrant. Wait, what, Andrew? Okay. And in your fourth quadrant, 300. So we have 4 answers just for that section, which this has never happened before because we've never had a 3rd degree polynomial, have we? No, because our reference angle is 60, guys. So 180 minus 60, 180 plus 60, and then 360, back it up 60. Okay? So those are our 4 for that. Tangent equaling 0. When does your y divided by your x on your red chart over there give you 0? It has to be when the y is 0, right? So the same place is that sine is 0. We have 0 degrees and 180 degrees. And so we have 6 answers. I didn't know that we were going to have 6 when I started the problem. But it kind of makes sense that we have more than normal because we've really only been doing quadratics so far, which quadratics breaks down to 2 mini equations, each of which usually has 2 quadrants. So we have 4 solutions. This is like a cubic. It's like a sine squared times like an x squared term times an x term is like an x cubed term, which would be 3 solutions, but because of the multiple quadrants, you could have upwards of 6, which is what we have. Got it? Okay. Oh boy. What do we think here? All right, there's going to be, because it's the identity world, there are multiple ways we can do this. Number 1 is we could immediately take out the cosine squared if we wanted. Anytime you have a mixture, like we had a mixture here, but it was factorable, so that worked out okay. This mixture of cosine squareds and sines is not factorable, so we want to get everything on the same page. So I could take out the cosine squared and replace it with what? Nope. I'm taking out cosine squared, and this would have to get subtracted over, so it would be 1 minus sine squared. Can everyone visualize that? So take that out and replace it with 1 minus sine squared. Eventually. I did my substitution right away, but my substitution turns it into a quadratic with sine. So now I'll distribute my 2 and subtract my 1 over. so that it equals 0. And when I combine like terms and put this in the proper order, the negative 2 sine squared x comes first, minus sine x plus 1. I really don't like my leading term to be negative, so I'm just going to switch the signs on everything. Technically, I'm dividing both sides by negative 1. And then I'm going to factor. Okay, Ellie, here's your quick tutorial. You know the word FOIL? Okay, what does F stand for? Firsts. So you have a binomial times a binomial. There's really 4 spaces we have to fill here. You look up at the board. These are your firsts. The first of the parenthesis and the first of the parenthesis. These are your last, so that's what your L stands for. Your outer are the outer 2, and your inner are the inner 2. So we need to find the 2 things in your first, is usually what people start with. What times what gives you 2 sine squared? Right, 2 sine times 1 sine. Does that make sense? Of course, we're doing this a little more complicated with sines involved, but 2 sine times 1 sine is 2 sine squared. And then usually people go to their last term, and usually there's more options, but because your last term here is 1, well, it's negative 1 technically, but we'll worry about the sign in a second. There's only one way to multiply to get 1, and that's with a 1 times a 1. But because these last 2 terms are supposed to multiply to get negative 1, one of these has to be plus and one of them has to be minus. And you can't just like throw it in there in any old way. Your outer and your inners, when you multiply your outer terms and when you multiply your inner terms, they have to combine to give you the middle here. So positive 1. So right now, I have a 2 sine x and a 1 sine x. I want the 2 sine x to be positive, and then I'll subtract 1 sine x from it, and that'll be 1 sine x. Okay. All right, so now if I tee it up, sine of x could equal a half, or sine of x could equal negative 1. For the 1/2, what's my reference angle? 30. And sine is positive in the first quadrant and the second quadrant. So the first quadrant version of 30 is 30. And the second quadrant version of 30 is 150. And then with negative 1, your reference angle could technically be 90 degrees. And because it's negative, you'd have to flip to, I mean, I'm looking at my red chart over there, you'd have to flip down to 270. Or you can just look for where your y-coordinate is negative 1, 270. And those are your 3 answers. Because it's not within a quadrant. So, like, if something is within a quadrant, you're going to have 2 answers. Because your reference angle is within the quadrant, and there's always 2 quadrants with that positive and 2 quadrants with that negative. If it's on the quadrant, if it's 0, you'll still have 2 answers. Like if the sine of theta is 0, look up at your red chart, you have 2 places where your y-coordinate is 0. But if it's 1 or negative 1, like those extremes, you're only going to have 1 solution. Because the other reference angle will just be the very opposite. Any questions on that? Okay, last one. Tan and a cotan. Ooh, what's your thought here? Cancel what? You were hoping? Yeah. Kind of what you got yesterday with the homework quiz. Something with that cancellation. If you were multiplying tangent by cotangent, it actually would cancel. But you probably want to make this 1 over tangent. So you have tan x minus 10 over tan x equals 3. But this becomes what type of equation? A fractional one, right? Where sometimes you get a common denominator all the way across. Have you guys done that? And then you drop your denominator, right? So put this over 1, put this over 1. What does this guy need? Tan x. And this one needs a tan x. This doesn't need anything. This needs a tan x and a tan x. And then you can drop your denominator. However, I will tell you, anything, if we get an x value that would have made that denominator 0, we have to reject it. Do you remember that? Like excluded values. So at the very, very end, when we figure out what we think our x is equal, we just need to make sure that of those x's, none of them make the tan of x 0, because if it does, we have to reject it. Other than that, our equation just becomes tan squared x minus 10 equals 3 tan x, and it's a traditional quadratic. So subtract that 3 tan x over factor tan x times tan x will give you your firsts. So here, Allie, we have choices for 10. We have 1 and 10, or 2 times 5. We want the combo to give us something like a 3, though. So 2 and 5 makes more sense. So I'll throw my 2 and 5 in there, and then I have to mess around with the signs. I want it to be a negative 3 in the middle. So I want my bigger of the outer product and the inner product. I want the bigger of those to be the negative 1. Perfect. So we get tangent of x equals negative 2, or the tangent of x equals 5. These are not memorized values. These are not things that come from your chart. These are things you have to use your calculator for. So I'm going to do inverse tangent of negative 2. This is just going to give me the reference angle, which is, well, reference angles are positive, right? But because inverse tangent gives me quadrants 1 and 4, and tangent is negative here, it's giving me that. But the reference angle is 63. And this reference angle is inverse tan of 5, 79. So for this first one, when tangent is negative, which quadrants are we talking here? When tangent is negative, 2 and 4. So 180 minus 63 will give me this one, 117. I think so. Check that. And then 360 minus, back it up to 63 degrees, 297. So there's my two answers for when tangent is negative. And then this other one is where tangent is positive, so we're talking a first quadrant. Reference angle of 79 will be 79. And we're talking a third quadrant, which will be 180 plus 79, 259. Thanks, Maya. Tomorrow we'll review and then test Thursday. You can just do the odds again.